Moving on to Unit 6, this is Lesson 6.1, Writing Linear Equations in Slope-Intercept Form. And your objective is to use slope-intercept form to write the equation of a line. So last unit we were given equations and we graphed the lines for them. This unit we're going to be given information about our graph, whether it's the line or just the slope or something else, okay? And we're going to have to write the actual equation for it instead. Alright, so let's get started. Okay, we'll start off with a nice easy example here. It says write the equation of the line whose slope is -2 and y-intercept is 5. So first thing is we'll want to remember slope-intercept form because that's the easiest to deal with. So that's y equals mx plus b. Well, they're telling us our m is -2 and our y-intercept b is 5. So all we have to do is plug those into our y equals mx plus b format. Well, I don't know my y's. My m is -2 times x plus, and my b is 5. And I'm done. Okay, so the equation of that line is y equals -2x plus 5. About as easy of an example as you can possibly get. Alright, let's move on to some more difficult ones. Okay, here we're given the graph. Okay, and we want to write the equation for the line shown. So step 1 says to pick 2 points and then use those to find the slope. Alright, so when we pick 2 points on the line, we want to pick 2 points where the line intersects in a spot where we can tell what it is. So again, we wouldn't want to pick like this point right out here in the middle, okay, because we don't know what that is. But like this one right here looks to be pretty good, right on the grid lines. And we're going to look again until we find another one. Oh, about right here looks pretty close. Okay, now on your book it'll be pretty easy to pick which ones where the line crosses, okay, and they might even pick them for you. But for your test and quiz, your answer might be a little different than mine, but I'll give you credit for it if your points are not exactly the ones that I picked. Okay, so first thing is we're going to find the slope. So I need to write my 2 points first. Well, the first point I picked was 0 and then 1, 2, 3, 4. So we've got a 0, 4. And my next point was -2, -1. Alright, so let's do x1, y1, and x2, y2, and we got to find the slope. So we're going to put -1 minus 4, y2 minus y1, over x2 minus x1, -2 minus 0. Okay, well, -1 minus 4, that's -1 plus -4, which is -5. -2 minus 0 is -2. Or -5 over -2, we can't leave that because a negative divided by a negative is a positive. So m equals 5/2. Okay, we need to find the y-intercept of the line. Well, we already did that when we picked out this point. Okay, so step 2, first of all, that was all step 1. Okay, step 2, our y-intercept is b equals 0, 4. Okay, because it was 0 and then 1, 2, 3, 4 going up there. Now we need to write in slope-intercept form. So for step 3, we're going to use y equals mx plus b. Write down the information. We know our m was 5/2 and our b was 0, 4, which means our y-intercept is 4, and we're going to plug those in. So we get y equals 5/2 x plus 4. Okay, well, we should be able to check this, and let's say I picked another point on the line right here. If I go up 5, 1, 2, 3, 4, 5, and over 2, I hit the line again. That's good. That means my slope is dead on. Okay, and if from here I went up 1, 2, 3, 4, 5, and over 2, we're still on the line again. And from here up 1, 2, 3, 4, 5, and over 2, still on the line. So our slope is correct. Okay, now again, sometimes on your test or quiz it might be a little tough to tell exactly where the line crosses when you pick your points, and I will take that into account. If you're not exactly correct, don't fret it too much. But for general rule, that should be able to use your rise over run to tell if your slope is correct. Okay, and our slope is positive because our line goes uphill. Alright, let's move on to another example. Okay, looking at this one, we're going to use the exact same steps that we just used. First thing is, we got to find the slope, and we're going to pick 2 points from our line. Well, I think this point looks good because 0, 0 is always really easy. And let's pick this one right here too. That is 1, negative 2. Okay, and we'll make these x1 and y1. Anytime zeros are involved, it's a good idea to make those your sub 1s because then you can just subtract 0. Okay, so we got x sub 2, y sub 2. And we plug these in. y2, negative 2 minus y1 is 0. Over x2, which is 1 minus 0. Negative 2 minus 0 is negative 2. And 1 minus 0 is 1. So our slope is m equals negative 2. And we can check that to make sure it's right because our line goes downhill. Okay, and if we go down 2 and over 1, we hit the line. Down 2 over 1, hit the line. So our slope is correct. Then we need to find the y-intercept, the point where it crosses the y-axis. Okay, well, it crosses the y-axis right here, right at the origin. So that point is 0, 0. Okay, and then step 3, write this in y equals mx plus b form. Again, now notice on both of these examples, I've shown all of my steps here, all of my work with the steps Mr. Ayers gave me. Make sure you do that. So step 1 is always here. Step 2, find the y-intercept. Step 3, y equals mx plus b form. Write down what you got. My slope was negative 2. My b was 0. So in slope-intercept form, that's y equals negative 2x plus 0. Or, we don't really need the 0 on the end. We could just say y equals negative 2x. Okay? Either one of those will be perfectly acceptable for an answer. Okay? Until we get used to slope-intercept form, I'd prefer you see it, or to see you write it like this. Okay? But most of the time, your book will use this form. All right, let's move on to another example. Alright, here we're going to go through the same exact steps. So step 1 was to pick 2 points from the line. Oh, let's just pick, I don't care, this point right here and this point right here. Sounds good. Okay, so our first point is at negative 3 and positive 4. And our second point is at 2 and positive 4. So we got x1, y1. And x2 and y2. Okay, so y2 minus y1 is 4 minus 4. Over x2 minus x1 is 2 minus negative 3. Okay, 4 minus 4 is 0. 2 minus negative 3 changes to plus. So our m equals 0. Okay, step 2 is to find our y-intercept, our b. Where it crosses the y-axis, well, that appears to be 0, 4. And step 3 is to write this in y equals mx plus b form. Okay, so our m was 0, our b was 4, so we're just going to plug those in. Y equals 0x plus 4. Well, we got no x's, so we could also just call this or y equals 4. Either way. Now, some of you may get used to seeing this, okay, and realizing that this is y equals 4. For now, don't take the shortcuts. Don't just write your answer like this. I want you to show all the steps here until we get used to using all the steps. Okay, at some point, if we get better with these, I will tell you don't need to use all these steps. But for now, while we're getting used to writing the equations, we got to get the steps down. So just keep using them over and over, okay? Let's do one more example. Okay, a plumber charges $66 for the first hour of a service call and $45 for any additional hours. It says, write a linear model to reflect the plumber's charges and use the equation to determine the cost of a 3-hour service call. Then, why should your equation have a positive slope? Okay, well, what do we know / not know? Well, we know that it's $66 for the first hour Okay, we know it's $45 for additional hours. And that's it. Okay, we also know that we're going to find the cost of a 3-hour service call. So assign labels. Well, the cost, we don't know the cost, the total cost, okay? So I'm going to put C equals the total cost. Then we need a variable for the number of additional hours. So X is going to be the number of additional hours, because we don't know the number of additional hours. Okay, because that changes. We could have 1 additional hour, 2 additional hours, 3, whatever it is. So it's going to have a variable. Alright? So, plumber charges 66. Now we need the verbal model. So our verbal model is our total cost is going to be equal to the cost of the first hour plus our additional hours. Okay, cost of the first hour plus cost of the additional hours. Now write the equation. We get C, total cost, we don't know what that is, equals $66 for the first hour plus $45 for each additional hour. So that's going to be $45 times each additional hour. So X. Now just because we're used to this, we're going to put C equals, so like Y equals 45X plus 66. Okay? Because that's more like slope-intercept form. Now, why should our equation have a positive slope? Well, think about this. If we were to graph this line, it's got to have a positive slope, means it's going to go up from left to right. And the reason for that is because if our line goes up from left to right, that means our cost is increasing for each hour. So the first hour is here, second hour is here, third hour is here, and so on. The cost should be going upward. So it should have a positive slope. If we're having to pay more money, the more time we go. Okay. Now it says use our equation to determine the cost of a 3-hour service call. So now we're going to take 3 hours and plug it, or 3 and plug it in for our hours. So we're going to say the cost is equal to $45 times 3 plus 66. Okay. Well, 45 times 3, that's 135 plus 66. And 135 plus 66 is 201. So it's $201 for a 3-hour service call. Alright? Okay, if you got any other questions, ask. Otherwise, good luck on your homework.